So students, in the last video we were discussing the magnetic quantum number, and we were looking at this value of principal quantum number, which was like when n is equals to 2, the azimuthal quantum number will be equals to 1, and the value of magnetic quantum number can be +1, 0 and -1, and the number of orbitals is 3, corresponding to 3 p orbitals with their orientations parallel to 3 coordinate axes x, y and z, and that is called px, py and pz. Now students, like if you analyze the position of electron in this space, like in an atom, the electron can have 3 dimensions, like it can be on the x-axis, it can be on y-axis and z-axis. So if it is like in the p orbital, so it can possibly be oriented in these axes like px, py and pz. Similarly, for L is equals to 2, if the azimuthal quantum number is equals to 2 and L is equals to 3, the number of orbitals will be 5 and 7 respectively. And each of these orbitals can accommodate 2 electrons. Like if like this degenerated orbital or the suborbital px, py and pz are here, so the maximum number of electrons which can be accommodated in px is 2, and in py it will be 2, in pz it will be 2. So the maximum, if you count 2 plus 2 plus 2, 6. In total, if you see, the p orbital can accommodate 6 orbitals, but the suborbitals like px it can only accommodate, it can only take only 2 electrons in here, and 2 will go in here and 2 will go in here. So in total 6, but this suborbital will have maximum 2 electrons. Similarly, for d orbital and f orbitals. Now this can be shown in the table 1.5. Now let's see what's been shown in table 1.5. This is table 1.5, and they have shown you here, if the principal quantum number is 1, then n minus 1 will be 0, and therefore it has only one orbital, one possibility, 1s, and the magnetic quantum number will be 0, and number of orbitals will be 1 only. If the principal quantum number is 2, azimuthal quantum number is 2 minus 1, so it can have 0 and 1. Okay, and the orbital designations will be 2s and 2p. Magnetic quantum number can possibly be like -1, 0 and +1. So there are total 3 possibilities. If principal quantum number is 3, it can have the azimuthal quantum number 3 minus 1 is 2. So you will go from 0, 1, 2. And the orbital possibilities will be like 3s, 3p and 3d. And the magnetic quantum numbers -1, -2, -1, 0, +1, +2. This is the maximum here, magnetic quantum number. For 3p, it will be -1, 0, +1. And for 3s, it will be 0. Okay? And the number of orbitals here for 0 is 1, like 1s. And for this, it will be 3. And for this one, it will be 5. So this is for s orbital, this is for p, and this is for d orbital. If the principal quantum number is 4, the azimuthal quantum number will be like 4 minus 1 is 3. So you have to go from 0 till 3. 0, 1, 2 and 3. And the orbital designations will be like 4s, then 4p, then 4d, and for this it will be 4f. And the magnetic quantum number, what are the possibilities of magnetic quantum number? Like for this orbital it will be 0. For this one it will be from -1 till +1 to 3 are here. And for 4d it will be like -2, -1, 0, +1, +2. In total there will be 5. And for this orbital, there will be from -3 till +3. So in total, if you count, how many are there? 1, 2, 3, 4, 5, 6, 7. And this is 7. Okay, now let's try to understand what is the spin quantum number. This quantum number is associated with the spin of an electron in the atom. Now, how the electron is spinning in the atom? So it can be told by this quantum number. All the electrons spin either in clockwise direction or in anti-clockwise direction when the magnetic field is applied. Like if the atom is exposed to a magnetic field, then what will happen? The electrons will start spinning around their own axis, and it can be like clockwise, in the clockwise direction, or in the anti-clockwise direction. Like 50% chances are like clockwise direction, and in 50% cases it is like anti-clockwise direction, and it is denoted by +½ and -½ values. So +½ will show you a clockwise moment, and -½ will show you anti-clockwise moment. This quantum number is denoted by the letter S. It is also a measure of the number of units of magnetic moment associated with a given electron due to its interaction with a magnetic field externally applied. Like when the electron will show spin quantum number when an external magnetic field is applied. This is not the magnetic field of the electron. You are providing an external magnetic field to the atom, and as a result of that, the electron will start spinning. So the value of the momentum is given by Planck's quantum upon 2 pi. Since the atom is spherical, so you can place this value here, 2 pi, and it can be positive and negative. Like if it is clockwise, it is positive; it is anti-clockwise, it is negative. So the angular momentum is then given by, this is the formula for angular momentum, and they have replaced the values of spin quantum number here. So the positive value has a lower energy and the negative one has a higher energy. Now you can see here, this is the spin quantum number and this is the axis of an electron, and when an external magnetic field is applied, it will start spinning like in this direction. This is clockwise direction and this is the anti-clockwise direction. So this will be positive spin, this will be negative spin. Now if you just want to conclude, or in a nutshell, if you want to see the quantum numbers, let's see this picture. Now you know that this n is the principal quantum number, and it can be also called as the shells, the K shell, L shell, M shell, yeah. And how you can calculate that? Like if they can be further divided like this: 0, 1, 2 and 3. What are these? These are the azimuthal quantum number. Like n can be 1, 2, 3, 4, 5 and so on and so forth. But for L, how you calculate L? You will subtract the value of n with 1. Like if the first shell is there, K shell is there, so how will you calculate azimuthal quantum number? You will subtract 1 minus 1, so it will come 0. If it is in second shell, so it will be n is equals to 2, and for azimuthal quantum number it will be 2 minus 1, it will come here. And similarly here, if it is 3, 3 minus 1 is 2, and for here like also. If it is in fourth shell, like 4 minus 1 is 3. Now these are the subshells for this. For 0 it is S, for first it is P, for second azimuthal quantum number it will be D, and for third it will be F. And these are the magnetic orientations. You can see here for S, 0 magnetic quantum number. For P there are 3 possibilities: +1, 0 and -1. For D, there are 5 possibilities, +2, +1, 0, -1, -2. And for F, there are 7 possibilities, like from +3, +2, +1, 0, -2, -1, -2 and -3. These are the F orbitals. Okay. Now, for principal quantum number, it is designated the symbol as N. Values can be from 1, 2, 3, 4, so on and so forth. And what it determines, it helps us to determine the size and energy levels. For hydrogen, energy depends only on N. And angular momentum or azimuthal quantum number, it is designated by L. It can have the possible values of 0, 1 and n-1, as we know, and it determines the 3D shape of the orbital. Like if it is 0, L is equals to 0, it is S. If L is equals to 1, it is P orbital. If L is equals to 2, it is D orbital. If L is equals to 3, it is F orbital. So these are the subshells. It tells us this about the subshells. And then comes the magnetic quantum number. Its symbol is M. And the values, as we know, it depends on the value of azimuthal quantum number, and we can calculate. And what it tells us is spatial orientation of orbit. Spatial means how the electron, or where the electron is present in the space. And in space, you know, there are 3 axes, X, Y and Z. So what is the possibility, or what is the availability of electron in the space? So it tells the spatial orientation of orbitals. And last is spin magnetic quantum number. It is designated by S or sometimes with MS, and it has values of positive half and negative half, and it tells you spin states of electron when an external magnetic field is applied. Okay, so I hope this topic is clear to you. Students, this topic is covered in 2 videos. To please go through both the videos. I will mark the video as quantum number 1 and quantum number 2. So please go through this video at least 3 times. Try to read the chapter from your book at least 3 times, and then make your notes on daily basis. Only then you will be able to understand these topics. I hope you all the best, and I hope that you are enjoying your e-learning. Thank you very much for your kind attention.